Hey everyone! Today we're going to learn about something that sounds fancy but is actually pretty fun once you get it. Recursion. So, what is recursion? Simply put, recursion is when a function calls itself. It's like a story where the character keeps going back to the beginning of the tale until something changes to finally end the story. In programming, recursion helps us solve complex problems by breaking them into smaller, simpler problems. Let's start with a simple example. Adding two numbers is easy, right? But what if I ask you to add all the numbers from 1 to 10? That's a bit more work, isn't it? Recursion can help us here by breaking the problem into smaller parts. Let me show you how with this example. So let's walk through what happens step by step when we call sum 10. First, the function is called with k equals to 10, and then the function says, I'll add 10 to whatever sum 9 gives me. Then sum of 9 says, okay, I'll add 9 to whatever sum of 8 gives me. This continues until we reach sum of 0, which just returns 0 because that's our stopping point. By the time everything adds up, here's what we have: 10 plus 9 plus 8 plus 7 plus 6 plus 5 plus 4 plus 3 plus 2 plus 1 plus 0, which is equals to 55. Now, here's something really important. Recursion needs a stopping point. Without it, the function would call itself forever, and your program might crash. So, this stopping point is called the halting condition. In our previous slide, the halting condition is when k becomes 0. At this point, the function stops calling itself and just returns 0. Now let's try a slightly different problem. What if I ask you to add all the numbers between 5 and 10? How do you think we can do that with recursion? Now, here's what we can do it. We have this example code shown in the slide. So, how does it work? In this case, the function keeps reducing the end value until it matches the start. When that happens, it just returns end. For example, number one, we have sum of 5 and 10 becomes 10 plus sum of 5 and 9. Then sum of 5 and 9 becomes 9 plus sum of 5 and 8. This keeps going until sum of 5 and 5, which just returns 5. So when it's all done, we will get 10 plus 9 plus 8 plus 7 plus 6 plus 5, which is equals to 45. Now, take note that recursion is powerful, but it actually comes with some risks. One is what we call infinite recursion. If, for example, you forget the halting condition, your program will keep running forever or until your computer runs out of memory. Second is performance issues. If too many recursive calls, it can use a lot of memory. That's really something to watch out in large problems. So, why do we use recursion? Uh, it might seem tricky at first, but it's actually super helpful for solving problems like calculating factorials, searching and sorting data, navigating trees and graphs, breaking big problems into smaller, manageable parts. It's also a really elegant way to write code. Once you get comfortable with it, you'll see how clean and beautiful it can make your solutions. So, recursion takes practice, but once you get it, it's like having a skill for solving complex problems. Keep experimenting and challenging yourself.